want to make the line, right? The simple linear line. Okay, but we have to, we have to find the suitable of theta 0 and theta 1. Okay. So let's turn back to here and okay. So in this case, if your model correct the theta 0 and theta 1 as 1.5 or 1.3 and 1.0, this means your model is, this is y predict, right? Y predict is theta 0 is plus theta 1 x, right? X. This is your model. And okay, let's take a look each one. Okay, the first one, x as 1, y as 1, right? If x as 1, the ladder is 1. So the second column y, this y I try to represent the y2. In this case, the y2 is 1. Right? Because this is x, this is y2. x, y, x, y, x, y. So this is 1, 3, 2, 5. Right? Okay, it comes from this one. How about the y prediction? The y predict is have to calculate from this model, right? So if you have x as number 1, right? X as 1, so y predict will be right. So it means y predict is 2.3. Okay, 2.3. What happens if x equal to, because the next one x is equal to, right? What happens? Right? How about the next one? How about the x equal 4? Okay, so you can get the y predict in this column. Okay. How about when you find the difference between the true value with the prediction values with square? Because we want to calculate the mean square error, okay? So that's why I try to make it square, because it is the term of this equation. Okay, so the first one is mean 1 minus with the 2.3 square, right? How much? 1.69. Okay. And the second one, it is 3, right? 3 divided by the periodic output. How much? this one 2 minus 4 by 3 right square เท่าไหร่ประมาณนะอีกไหมเนี่ย 5.29 Are you sure? Because you are not using the calculator. You calculate very fast. ถูกไหม
ถูก
And the last one is 5 with 5.3,
y prep
right?
เท่ากับ
0.09. So this is the you have to sum up all of this one, yeah, because the equation you need the summation of that, yeah. Yeah. What is the result? Can someone give me the answer? 7, 116. Let's check again. Okay, I don't know. Okay, so it's not finished. You have to divide it by number 4, right? We have 4 points, so it means the mean square error equal 7.16 divided by 4. Okay? How much? One point 79. This is the answer of the mean square error, okay? This is just example when you have only 4 points and you have the models that have the theta 0 and theta 1, right? If I change theta 0 and theta 1 and calculate like this again, maybe the mean square error is might be increased or decreased, right? But what is your target? Your target, you need the mean square error at 0. Because if the mean square error at 0 is mean your model is very good or is the best one. Okay, but in the real case, if it's not the perfect linear, you cannot get the mean square error as 0, you know, but we will get the answer or we get the mean square error as close to 0. Okay? But the question, what should we do or what the simple linear regression process for finding the suitable of theta 0 and theta 1? You have to random, right? Random again and calculate mean square error and how much you get, right? If you get like 100, it means you have to change theta 0 again and theta 1 also for decrease the mean square error, right? It's not easy, right? Because you have to parameter and you have to adjust or get the lowest error. Okay? We have one algorithm that behind the simple linear regression. The algorithm name is gradient descent. This algorithm is the algorithm that minimize the cost function. Okay, this algorithm is the basic one that try to finding the lowest error based on theta 0 and theta 1. Okay, so if you have seen this graph it has the theta 0 axis and theta 1 axis, and this axis is referred to the error. Okay. For example, if I point to this position, it means it might be referred to the theta 0 here, and theta 1 is around, for example, theta 1 is might be here, for example. Okay. It means if you get the theta 0 this point, theta 1 this point, you might be get the error around here. Okay. What happens if I random another point? If I random to another point, it will affect to another values of the error. But the best one that we want the point that is lowest of the curve. Okay, the lowest point, because the lowest point is might be close to 0. Okay. Okay, we have one more thing to make you more understand. It is a very basic one of the mathematics and also it is the background of the gradient descent. Okay, why? So if you have this equation, okay, it's like the parabola equation, right? Like this. Okay, this is the equation of the parabola as the lowest point as the x equal to, right? Okay, I think everyone learned about the differentiate, right? Dip, right? And f, how can we dip this equation? Right? Dip, get that? Okay. Okay. What is the dip when you do like the differentiate? What is the meaning of differentiate? Gradient. Like you want to find you want to know the parameter changing, right? How much it changed, right? So this is the meaning of different. So okay, if I represent x equal 1, okay, okay, from this one, I represent x equal 1. Minus 2. So what happens if x equal 3 from this one? It's 2, right? What happens if x equal to 0, right? So when you see this graph, x equal 1 is in this position, right? This is x, right? This is y. X equal 1 is around here, right? And for example, okay, but what is the meaning of the negative and positive? when you do the differentiate and you get sometimes it's minus, sometimes it's positive, right? The symbol or the negative or positive is mean the direction that the parameter changing. Okay, if it's negative, it means the parameter is going down, right? And the positive is mean the parameter is changing in the going up. Okay, so it means if x equal 1, it means it's going down, right? But if x equal 3, you can get the differentiate as 2. It means the parameter is going up. Okay, but if you take the x equal to is 0, 0 is mean is nothing, is no change, right? In this position is 0, it means not going up, not going down, right? It's either flat, right? So this gradient descent, the background of them it comes from the differentiate. To know that if the parameter, if you did the equation and you can get the answer as minus, it means your parameter is going down. So you have to adjust the parameter in this direction, right? Because we need, we need to get the 0 at the finally. And if you know that you are going down, so that is you are go to the correct direction. But if your parameter already positive number, it means you are far from the 0 position or the base position. You have to adjust parameter to put the variable to go back to the 0 position, right? Because you know the direction from the answer. Okay. So the concept and the background of the gradient descent it looks like this, quite different. So let's take a look at this one. You can see that. Okay, if you have the parameter of input x and y, okay, and you have the data set at the blue dot, you have the many data point scattered point on the graph. So when you change the model, when you change the line, it means you are changing the theta 0 and theta 1. Okay, because each line is depend on theta 0 and theta 1. And it is the relation to this graph, because this graph, the best one is close to 0. But if you change the position of them, it's going to change the value of the cost function depend on the parameter theta 0 and theta 1. Okay. Actually, we have another one, like another vocabulary for the machine learning. Another one we call the learning step. Okay, maybe one example in the neural network, we have one parameter, but not today. Okay, but we can set the learning step or learning rate to it is to one parameter when you train the data. If the learning, let's take a look at this one. For example, if you set the small learning rate, your process of learning will be slow. It's going to learn each step with the small value changing. For example, if you want to get the lowest point, but right now you have stay here, okay? And if you set the small learning step, it means it's going to change a little bit and learn it again. Change it a little bit, while learn it again, okay? But the advantage, you will get the it has the possible to get the lowest error or the best parameter, but it's very slow. By the way, if you set the learning rate is too large or too big, it looks like you might be jump up or you might be jump the lowest position. It looks like when you train the model, it have the cost function here, and if you set the learning step too large, maybe the next time it's going to learn in this point, and next time it's going to learn this point. So it's possible to don't get the lowest point because you set the learning rate is too big. Okay. And if you would use this constant big learning rate, you would jump around the minimum point. Okay, but if you constant small learning rate, it would take a lot of time on work. Okay. Today is maybe a lot of mathematics. Okay, maybe a lot of details, and also I will explain you more about the gradient descent algorithm in the example. Okay, this one is another cost function. Is the previous one is the mean square error. Okay, but this one we call the sum square error. Okay, the sum square error is similar to the mean square error, but we just compare between y true and y prediction square, and each time you have to divide it by number 2. Okay? And also this one is also the step of the gradient algorithm. Okay, but don't worry about the step, and we show you later. But the step will be random. Okay, because the first time you don't know what should we select theta 0 and theta 1, right? We don't know. So if you don't know, you can random. You just random, and then you calculate the cost function. Okay, maybe the cost function is high. If the cost function is not good, you can calculate the next step for adjusting the theta 0 and theta 1. That the theta 0 and theta 1 is can affect from the sum square error or the cost function. It means if you want to find the effect when we use theta 0 and theta 1 with the cost function by using the we call it partial differentiate. Okay, and then you can, after you know the effect that from the error, you can calculate for updating the parameter of theta 0 and theta 1, and then you calculate it again for the next round. Okay, so for example, maybe the first one you can get the blue, you random theta 0 and theta 1, and you can get the blue line. Okay, and then calculate, and you update the value. For example, the first one, the theta 0 as 0 and 0.25. Yeah, and the next round, when you update the theta 0 and theta 1, you can get the new theta 0 and theta 1 for the next round. Okay, and you update it again. Okay, update it again, update it again. So each time that you update is going to reduce the cost function. Okay, this is the concept. But okay, how we can calculate the step of gradient descent. Okay, that I show you here. Okay, I'm gonna explain you the step of gradient descent from this table. Okay. after this example, I will take a break for you. Okay, so okay, let's see this example. For example, you have x and y. Okay, you have input and you have label with the four numbers, four information. Okay, and the first round, as I told you, we don't know the parameter of theta 0 and theta 1, so you can random it. Okay, you random it, and this is the learning rate. Okay, the learning rate that I told you, like you can adjust small learning rate or big learning rate. Okay, I will show you later because the learning rate it is the one parameter when you want to update the value of the theta 0 and theta 1. Okay. Okay, let's take a look. Okay, x, y, and this one is y prediction. Okay, y predict. And you have known that the y predict is come from your calculation that come from the model here. Okay, like right now theta 0, yeah, 0.5 plus 1x. Yeah, this is your model. Yeah. Okay, this is some square error. Go back to this one. The sum square error. This is the equation of sum square error. Okay. Y2, y predict square. Okay. This is the cost function. Okay, I try to show you that not only mean square error, sometimes we can use the sum square error for the cost function calculation. Okay. So I think you might be have a question about what is, yeah, this is some square error, you know, but what is this and what it is, right? So I will show you what it is, okay? What is these two columns, okay? These, those two columns I show you what is come from this and this equation. Okay, for example, you know the chain rule, right? Chain rule, like when you have the function and v, right, and v is from h. This means this is the function y, right? It might have the relation to the another function, right? And this function is the function we have the relation to the another function. Like this is the chain rule. Okay. So I try to show you that, like so okay. Theta, I should be starting with theta 0, theta 1, okay? Okay. Okay, I will start to explain you about this one, okay? Try to calculate maximum slope from this one. Okay, I will show you that the sum square error it look like the chain rule. Okay, if you see this is the sum square error. Okay. if you consider this is like the function, this one, okay, it's similar to this, and if you focus on y predict, the y predict is, yeah, right, this is the y predict. Okay, the y predict is theta 0 plus theta 1 x. Okay, so this is y predict is related to this equation. Okay, it looks like it has the relation from this function to another function, right? And the y predict y output is calculated from theta 0 and theta 1, right? So it's like this is the y, for example, this is the y predict. It comes from another function that might be 0 or theta 1 effect to the y predict, and y predict is calculated in the another function that is the, like the shell rule. Okay. So, okay. If you see that, it means theta some square error is y predict, right? And this is the partial dip. Y predict is just now that you know that the sum square error is have the function of the y predict inside the equation, right? And the equation of y predict we have the theta 1 and theta 0, but right now we focus on theta 1. Okay? And the next calculation I will show you the theta 0, but this one I will focus only this. Okay, so okay, let's focus on this part first. Okay, we have two terms of the calculation, 1 and 2. Okay, but we're gonna start the first one. The first one is okay. So from this partial differentiate, okay. So we will differentiate reference with this only this parameter, okay. So 2, right? Dip you can dip this term, okay. Y predict, and this is the dip for the whole term, but don't forget to dip inside again, right? You have to dip the whole equation, and don't forget to dip only the whole only inside this term, because this term includes this one. So when you dip only this, you can get like -1, right? If you dip only here, only this one, you can get -1, and then it's gonna have only y2, y predict minus, right? Minus. Okay. So we have another one like the second term of this one. Y predict is here, right? It comes from okay, theta 0 plus theta 1 x. Okay. It's like the differentiate, but we will dip only comparing to theta 1. Okay. In this case, you can get only x, right? Because the theta 0 is like a constant. If you dip the constant, it means 0. Yeah. But if you dip this one, differentiate this one, is get the x. Okay. So you can get x for the second term, and you can get this one for the first term. When you multiply this and this, right, you can get that. Yes. X. So it means this one. Okay. Okay, it is the same answer. This one. Okay. This one is come from the step of gradient descent for theta 0. Okay. How about the sorry, theta 1. Okay. For the theta 0, it is the similar thing. Okay, but you just change this one to theta 0. Okay. Theta 0. Compare to theta 0, and it means SSE some square error is coming from the y predict, right? Y predict and y predict is can be effect from theta 0. Theta 0 is in the y predict equation, right? And in the y predict equation, you have some square error. So this term of this one as same as the first term here. Okay. So it means you can get this one. Okay. So you just calculate only this term for finding the answer, like y predict is theta 0 plus theta 1 x, and we differentiate with the theta 0. So this is the constant. Okay, this is the constant. If you did compare to the theta 0, this is the constant is 0, right? You have only this one. This means 1. Okay, 1. So when you combine 1, this is 1, right? And this is the same as previous value that we calculate. So that's why we can get this column. Okay, this is the solution of the output for these two ones. Okay. So let's see this table again. So okay, I think everyone can calculate this. This meaning is y prediction. Okay, this is y prediction. It's not average. Okay, so this is the y prediction. The y prediction that x equals 0, you can get y predict as 0.5, and then you can calculate the sum square error. Okay, from the sum square error, okay, the next one we can calculate the difference between y2, the actual y, compared to the y prediction, like this one and this one. Okay, you find the difference. Okay, minus 1 minus 0.5 and take it in the minus term. Okay, and this one, okay, you represent y as 1, y bar or y reading as 0.5, and x is 0. So you can get this one as 0. You know, you have to do this one in every point for calculate the process like this. And then if you calculate the process of each point, and then finally you can get the summation of some square error, summation of this one, summation of this one. Okay? Because when you find the summation of each one, you can go to the next step. The next step means step number 4. Okay, step 4, you can adjust or update the theta 0 and theta 1. Okay, by using this equation. So right now you have known the term of partial dip of the sum square error. These two ones you have already calculated, and you have known the learning rate that you define. Okay, so you can go back here and you can see that. Okay, this is the update theta 0 and theta 1. Okay, the theta 0, the first term is 0.5. Okay, this is the original one. Okay, and then learning rate 0.01 multiply with this one, and this one you have already calculated here, minus 8. Okay, so when you calculate, you can get the new theta 0 and also new theta 1. Okay, after you get this one, okay, we have to do like this again for the next round. Okay, you have to do again, and maybe this is the homework. Okay, you have to complete this one, and you can see that every time that you calculate the mean square error. Yes, this one. Maybe the next time that you calculate, it should be decreased. The value of error should be decreased when you adjust the parameter here, because the gradient descent algorithm to try to minimize the error in each round, that you try to adjust the theta 0 and theta 1. Okay, so this is the one homework. Okay, you can go back to your home and calculate something like this. Okay, and you can see that. Okay, step 1, step 2, step 3. And you can notice that every time you calculate the error or the cost function, it should be decreased every time. Yes. Okay. Do you have any question? This is the concept of the regression learning. Okay. Sorry, it might be have a lot of mathematics today, but okay, I hope you understand the background of the. Yeah, I know. I can teach you in the simple way, like okay, this is the regression. Just open the code, the program, and run it, and you got the prediction output. Yes, but I want to know also about the background of the learning process. Okay? And you can understand that the machine learning is not the fancy, it's just mathematics, right? And we have to update the parameter inside with some algorithm like the gradient descent and so on. And in every technique, it has a mathematics background. Try to adapt itself for getting the best parameter. Yeah, for example, the gradient descent is trying to get the lowest error by adjusting the theta 0 and theta 1. Okay. take a break 10 minutes after the break I will show you the example coding นี่มันเปลี่ยนไปเลยพอแล้วว่ามันดังโค้งตั้งแต่สมัยหน้าที่สองนี่ยังไม่รู้เลยพอหลายภาคเราก็
ไม่ก็จะเบียร์มือเหลือ
เลขสองแล้วไปแต่สองแบบสามไม่ต้องไปเรียนแล้วไม่รู้แบบทำสีแดงมาแล้วแบบไม่เป็นรูปของทุกอย่างตรงนั้นอ่ะสนุกอะไรโดนกินไปแล้วประหารชีวิตคนเลยประหารชีวิตคือ
ใคร
ไม่ต้องไปแดงเลย
ดำคือคุณที่ก็ออก
ไม่ให้มันโดน
ยิ้มขึ้นมาด้วยยิ้มทุกแบบรวมเป็นแบบ
ถวายทุกแบบนะเย้
ไม่ใช่ทำต่อเลยทำผสมกัน
ก็ถวายแล้วแบบไอ้เยอะเราให้คิดให้ถึงคือเรื่องเองอะเยอะต้องแก้ที่นี่สิ่งใต้เลยอ่ะแต่อันนี้กูเข้าใจอยู่เราอันนี้กูเข้าใจอยู่แต่ว่าอันนี้ไม่รู้ไม่รู้ไม่รู้แต่ไม่ยากแต่แบบเยอะเยอะคือมันจะไปงงแค่ตัวดึงตัวนี้ใส่นี่ก็จะไม่ต้องมีเบอร์
ก็ได้ต้องมีดาวแม่ดาวผมเลยเดียวดาวที่นั่งพอเราเองมากก็รู้หนึ่งสี่
กูนั่งตีกับไอ้พวกอีเมลก็ไม่ขึ้นก็ดีนะไม่ได้ที่เปลี่ยนเวอร์ชันก็เลยขึ้นมาไม่ดีอะเรื่องที่สิ่งอะไรเราก็แบบรู้ไม่ได้เปลี่ยนเวอร์ชันที่สามมาใช้อยู่ไม่ได้ด้วย
จ่ายก็จ่ายไปแล้วก็ไปสองแล้วก็หายไปไม่รู้ทำไม30 ไร รู้น่าจะก็รู้สึกที่ก็อาจจะจอนปีไปเลยอาจจะจอนอาจจะแบบมาแบบ
อ๋อเสร็จ
อยู่
ไม่
ที่
ไม่
มัน
ได้
มันตัวแค่นี้เราพักแล้วก็เสียบ
ก็เลยก็เลยจริงๆที่บอก
โอ้ยใจเด็ดยอด
มีกับว่า
แล้วดูก็ได้ใส่ตัวนี้ได้ใส่เลย
มึงทำอะไรนี่โอ้ย
ไปเรียนที่ไหน
มันน่าจะเดินได้ห้องเซลล์ห้องนี้เป็นห้องเป็นห้องอื่นเป็น
ไปทำรอยที่ไหน
โอเคเชื่อไหนกูได้ยินดิ้นรนกินอาหาร
เป็นห้องที่สามยาวเลยผมเป็นแง่คลองผมเลย
มีสายกินไหม
แต่มันไม่เจอ
อันนั้นมันต่ำ
มันฝัง
อ๋อ
ไอ้เนี่ยคือเจ็ดแต้มในโทรมาแต้มให้ลดค่าสมมติคุณลืมใช้สัตว์ที่หน้าดูแทนตัวตลอดเลยที่อ่ะดูไว้ไม่มันจะได้ดีได้ไหม
สายต่ำจับนี่แหละ
ผมเป็นแง่คลองแต่แบบห้องอื่นมันไม่เป็นไงเป็นห้องนี้ห้องเดียว
เรียนยังไงก็บอกแต่ที่
แบบที่ไม่เหลืออีไม่เป็นอีเหลือ
คือเนาะ
มันถึงแม่
ผมก็ใส่เลยได้หรอ
ต้องบอกตัวกันอ่ะ
3 เมตรไม่รู้ภาษาอังกฤษเช็คได้ไม่ดีเลยไม่พอ
ถ้าเกิดเขาร้องไม่ดีเนี่ยไม่ร้องกลัวมั้ยก็อยากจะกลัวไม่เหมือนเปลี่ยน
ผมไปสอนคนอื่นเป็นในห้องนี้สายยาวมากนี่นี่เขาใช้แบบ2 ชั้น
เขาเรียกว่าอัดแต่ลมมือ
เกมคลาสสิก
อย่ามาขยับเชียวนะขยับพวกเพื่อนที่
การรู้เรื่องเลยนี่
ต่อเอา
ไอ้เหี้ยเย็นเรื่องทำเรื่องตัวไอ้เหี้ยขี้ไปตัวเล่นเนี่ยเหี้ยปุ๊บดินนี่อ่ะในวันนี้ตอนเด็กๆเนี่ยเรื่องผีเนี่ยเนี่ยแอบอยู่ดีตอนแรกมันคือที่มันบอกว่า
โอ้
อะไรอะไรที่การใช้วิธีนี่ใช้วิธีสั่งนี้นั่นเลยมันไม่เป็นกลัวเขียนนั้นนวดกลัวเขียนนั้นนวด
ตอนที่เราใช้สาม
กลัวเขียนนั้นนวด
มากลม
กูคิดแล้วไม่คิด
เหี้ยวิโก้อะ
3 เดือน
เหี้ยพูดถึงว่าถ้าไม่มีเขียนเขาวิโก้แล้วขีดอะไรเงี้ยคือรู้ว่าแดกยาเลยเหี้ยไม่รู้มันโอเลยเหี้ยมันจะแดกยาแก่กว่า
โอ้โหล่าสุดมีขึ้นแบบปุ๊บเลย
หนาวหนาวปะหรอนี่คือใครวะ
ปวดช่วย
นี่ขวดแล้วนะ
ฮะ
นี่ขวดแล้วนะ
เฮ้ยวัวเปิดของเราเลย
คือตอนนี้ปวดแล้วก็เวลาหาจน
ต้นลากยาวแต่ต่อไปเลย
มันขวดเป็น
กูปวดแต่เช้ากูปวดแต่เช้า
คือเวลาเนี่ย
กูเลยไม่มาไงเนี่ยเวลาตื่นอย่างนี้9 โมงหัวกูไม่ไหว
Let's open the file. Actually, it's the file of the weight and height in the Google Sheet. The last time if you for input your weight and height, yeah, you can use that file for doing the regression. Yes, and you can open the regression one. The Jupyter the Python file that I upload in the Google Classroom regression one, simple linear regression. Okay, you can implement your weight and height CSV file in the Python example.
ำไว้จ่ายเงินมาทันทีไม่ยอมครับถึงไม่เคยมีวันนี้
ยิ่งได้เลยหน้ามันขยับอ๋อตัวแปร เคยใช้ได้เนี่ยเลยใช้ได้ดีก็ของผมมันไม่เคยใช้ก่อนรออีกสัก
มีรู้สึกว่ารู้สึกว่าเขียนมือเองเนี่ยเขียนที่งานได้ชั่วโมง3 ชั่วที่ที่เดินมาประมาณชั่วโมงที่ไหน
เฮ้ยได้แล้ว
เลย
เปิดได้ปุ๊บเราไปหาเราไปหาเลยอะไรวะเนี่ย
โยโร่เนี่ยโยโร่ไงโยโร่จะได้เหมือนทีนี้เลย
อะไรวะ
รู้ไปแล้ว
เอ๊ะปวดหัวชีวิตอะ
เขียนเนี่ย
ไหนวะ
พอเอาเวลาแล้ววันแรกมากินเวลาแค่การเรื่องการเนี่ยก็เพื่อเอาแบบนี้ดูแลที่ธรรมดาใช่ป่ะก็เลยเป็นเพราะทุกวันนี้มัน10 บาทครึ่งวัน10ก็ไม่เสร็จเพราะว่าค่าเวลานี้คือค่าเวลาที่ตกเรานอนที่วิ่งวิ่งเดิน
กูลองซื้อละ
ไม่รู้อยู่ไหนเนี่ยไม่รู้อะไรตัวนี้เหนียวขึ้นกว่ามันก็บอกเส้นอื่นมันก็ขึ้นแค่นี้หรือรถก็ถึงขั้นเราบอก
ลองได้นะเรื่องนี้มีพอร์ตตัวเองใช้ฟรีใช้ทางเก่าไม่เป็นไรเลิกเรียนอีกไม่ได้
กูไม่แกล้งเก็บลายเลยแน่
ไปมาเรียนต่อเลยนะหากองเพื่อนใหม่ของที่จะทำแบบ
ไม่ไหวเลย
ยัดแบบออกไป
การใช้คอมพิวเตอร์เป็นแบบนี้
อะไรนะ
ใช้คอมพิวเตอร์เป็นแบบเราที่เรา
เอางานจากถ้าเราเรียนได้
เวลาจะมาจับ
อ๋อต้องก็เป็น
ไม่ยอมจับไม่ยอมจับ
หาตัวมา
เอาจับ
ถ้าอยู่ไม่เป็นนะผมไปขอนะขอบางห้องก็ไม่ห้องก็จับ
rồi cái bộ lưỡi phải lấy kẻ ok
เย้ได้ละ
เอ่อ
แข่งกันอย่าเดินที่เป็นโกเมาส์เป็นโกเมาส์เดินแรงความดันเนี่ยเบาๆ Okay, this example is very simple example. Okay, we have the around 7 steps. Okay, the first step you have to import the data set. Okay, that I show you. You can use your weight and high data set. Okay, the last time you implement in the K-mean clustering. Okay. Okay, for my file name, okay, I put the weight and height. Yeah, but it depends on your file name. Yeah, I read from my file name as here. Yeah, and
thank you
okay. Sorry. That's the progress about the connection.ห้องผมมันมีปัญหาการใส่ของแต่เราไม่เป็นไรห้องอื่นแต่ห้องอื่นใส่มันไม่ยาวไม่ได้เกี่ยวห้องอื่น
โอ้โห
เอาอะแดปเตอร์เหล็กมาต่อเป็นไทป์ C ได้มันติดแล้วพอดีเหล็กเขามีอย่างนี้ก็เลยมันเป็นเทคนิคไหมครับ
ไม่รู้อยู่ตัวนี้ครับผม
หาตำแหน่งเจอไม่เจอ
น่าจะ
แล้ว
เป็นลูกค้าแบบก่อนตั้ง
ไม่ได้ทำลุงผู้ดีนี่อะไรวะเนี่ยตอนนี้วะ
แบบนึงนะ
นี่เป็นมาเตอร์สีขาวนี่ก็ยังเป็นอะไรอะไรจะเป็นมาเตอร์ขาวจริงๆแล้วจริงๆขังจอเลยนี่นะ
โอเคคือวันนี้อันนี้ก็คือเรื่องอันนี้มันเอาว่าเราไม่ยอมลงเดียวตัวอันนี้มันเลยไม่รู้
อะไรไม่รู้เลยขังจอไม่รู้ไม่ได้ถือใหญ่อยู่
วันไหนวะ
เอาผัดครับ
รู้คือกัน
หน้าแต่ละตัวไม่กูหาอยู่
นักเรียนด้วย Okay, it has the problem about the Wi connection. Okay, maybe we will continue the contents next week. Okay, but okay, I will talk a bit about the assignment too. Okay, for the assignment one, the last time we have the presentation about the generative AI, right? So I think about the assignment two right now. Maybe I want you to do the like YOLO, you know, YOLO. YOLO. You can search through the internet. The YOLO it is the popular model for many applications. For example, the object detection. Object detection is performed in the real time. Real time. Object detection. Okay. And right now it has a lot of versions. Yes. But in the website, if you focus on the YOLO analytics, it will start from the version number 3, 4, 5 until I think right now is 12, and it just have the newest version is not 12 but 30. Ultra Lighting, yeah. Ultra Lighting YOLO and YOLO, yeah, YOLO E, maybe it is the newest version. but not today. But I will introduce like the YOLO. What is the YOLO? Actually, the YOLO it is the real-time object detection. Like you want to detect the object in the image, then you just created the model that the YOLO apply you already, but you just apply the input by the image, and you have to label the object you want to detect. You know, when you input the image or the video, maybe you have a lot of background, but if you focus only the human, you have to label like the boundary, the area of the human, and teach the YOLO for learning about the human object. Or if you want another object, you can label or boundary that object. Okay, but normally in the YOLO model, it already trained the basic object around 80 objects or 70 objects around. Yeah, it already trained it for you, like the basic, like the human, like the chair, the table, the computer, and up to 80 classes or 80 objects. And not only that, some version of the YOLO, it can do like the segmentation. What is the difference between object detection and object segmentation? Okay. The object detection, if you see the example in the website, the object detection is only make the square blocks to detect that object. Okay, but the object segmentation will be more precise. Like if you want to detect, if you want to segment the human, it will be not make the square to detect, but it will focus in like the age of the human, like the age of the human, like this. Okay, so it's more like it has a more complex than the detection because it has to focus every single point around that object. Okay, so we call the segmentation. And some version of the YOLO, it can do like the post estimation. For example, if you want to detect this pen, yes, if you want to detect, it might be have only the box to tell you that this is the pen on this position, but the post position, the post estimation, it can give you more detail, like this is the top and this is the bottom of the pen. Okay, it's not only this is the pen, but it can provide you more details. The position of the left, right, or up or the bottom. Okay. So the three main purpose, okay, you can find in the YOLO. But some version it can perform only object detection, but some version it can perform all of them. Okay. So I think right now I'm thinking about this one for assignment for the assignment 2. And maybe I will random like this group. You have to focus on the object detection, and this group maybe you have to focus on the segmentation. This group, another group is focus on the post estimation. Yeah. But not today, not assigned today, but you can start to study yourself and your group about the basic of the YOLO. Okay. Because you can search in the YouTube or the tutorial right now. The YOLO is maybe you can see only 2 or 3 lines of program. This can be run. Only running the program. Maybe you just import YOLO and the next line is maybe predict YOLO and it can be run the program. But in the assignment, maybe I will assign you to train it by yourself. Also, it's not only download the models and run it, but I want you to train some new models. Okay, that not include in the original model, because the original model is maybe include 80 class or 80 objects, but maybe I will assign you to do like special object. You have to train it by yourself. Okay. And maybe this assignment, do you want to make the presentation in the final, or you want to make only the report? Which choice do you prefer? Make the presentation, or I think it's two person per group. Maybe the same as the previous. Yeah. So you can start to study yourself about the YOLO. What is the YOLO, and study about it, how to train it. Yeah. But maybe the next time or next 2 times, I don't know, I will random and give you like this group object detection, this group segmentation. Yeah. And maybe you can select the version you want. Yeah, because we have a lot of versions like version 3, 4, 5 until 11. Yeah. เห็นไหมเฮ้ยกลุ่มนี้ยังไม่ได้มีเซตติ้งใช่ไหมยังไงครั้งหน้าพร้อมไหมเอาเลยนะใช่แล้วทำเดียวเลยครับ
เซเว่